Send me something.
Oh, I thought we were going to continue on that work we were doing last time. Do you want me to grab that link again?
Let's see if I can figure it out. I think I have it. Same link.
Yeah.
I think I have it. Hold on a second. That was from
Tuesday, I believe.
It's funny, I looked at that today and I thought I put it in. Oh, this must be it right here. Let's see if that's it. Hold on a second, I'm using a Office clone here and it takes a while to load it up. That should be the link right there, I think. Hold on a minute, I'll be able to see it. Yeah. This is it, right?
Yep. 1 second. I'm going to mute because I'm going to sharpen a pencil real quick. It's loud.
Okay, that's fine.
All right, I'm back.
Okay.
We left off on G because we did F at the very end.
Okay.
On
I know you're tutoring with David.
Yeah.
We did not do.
Wait here. One second, David. My dad wants to talk to you for a second.
Okay. Hi, Lauren.
Hi, how are you?
I'm good.
Turn it down. I just wanted to say I'm trying to figure out the online pay stuff, so I didn't want that to be a concern of yours. I appreciate you working with Josh and doing this, and I will get things resolved hopefully today, if not tomorrow, trying to get the payments put in using the online system. That's how you'd like to do it, right?
Yeah, and let me just say that my website where it's the easiest is digitalmathtutor.com.
That's where I've kept it, and so I'll go back there. But
okay. I do have another website. It's a little bit more difficult to pay. You have to send an email to my address, but yeah, on Digital Math Tutor, it's two clicks, I think, to make a payment through PayPal.
Okay. All right. And the only other thing I'll say is if you and Josh are having connectivity problems, the local Comcast internet's been tricky out here. So if there's any issues, we'll try to get that resolved too.
Okay. I had a problem with that yesterday. Hopefully I won't keep having it today. So, all right.
All right. Well, I'll let you go back to Josh.
Okay, Lauren. Thank you.
Hello.
Hi. Okay. Let's see. We did not do G.
Yeah, we did not.
Okay.
We finished on F, I think,
Yeah.
because we were supposed to finish on E, but I was like, but how do we do F? I was like kind of interested in that, and we did that real quick.
All right. Well, let's take a look at G. What's the, first of all, you notice it's a quadratic in all of its glory. In other words, it has an n squared, it has an n, and it has a constant. What's the first step?
Well, we have to do the parentheses, obviously.
Actually not. In other words, I want you to get used to the first step always being greatest common factor. because that can reduce these. Some of them that are extraordinarily hard are simplified quite a bit if you can pull out a greatest common factor. You should always look for greatest common factor as the first step.
Got it.
Is there a greatest common factor that between those three terms?
I do not know because I don't really know what the greatest common factor would be.
It's 3.
3.
In other words, I can divide everything by 3, and I'm left with this. And now notice that that's far easier to factor than the original one was.
Yeah.
And that's why we do it, is when you take out a greatest common factor, you're left with a much easier problem. Now, the one thing you don't want to do is forget to carry forth that 3, but it turns it into this, whereas inside the parentheses, we're factoring 5n squared minus 9n minus 2. So let's use the methods we've learned. First step.
We split the 5 and 2, but we only put 5n in one of the parentheses and put n in another.
Yeah, the one thing you always do is split up the variable. In other words, 5n squared times 1 would not be a satisfactory answer. You always have to at least split up the variable. And that does it. 5n times n is 5n squared. Second step.
Second step is to figure out the sign, but with these it's much more trial and error, so it's plus and minus on both sides until we figure it out.
I'm going to put a plus minus there, and because these coefficients aren't the same, I'm also going to have to try minus plus. Now, the good news is there's not very many factors of 2.
There's only one.
That's correct. So let's just start with 2 and 1. And we're going to do trial and error. Now, what does that produce as a middle term? What's the top
first
smiley face going to be?
2n.
What's the bottom smiley face going to be?
4.
Minus 5. In other words, it's minus 1
negative 5.
times 5n. Now, notice that when I add those two together, I don't get the right number. And if you don't get the right number, then there certainly is no point in moving the 2 down to the negative sign and moving the 1 to the positive sign, because that doesn't change the numbers. All that does is change the sign from a minus 3n to a plus 3n. Okay? Which means I can eliminate that from my trial and error. I know that it's not minus 2 times plus 1. So instead, let's try the other thing we can do, which is switch the numbers. Put the 1 there and the minus 2 there.
Got it.
Let's see what we get as a middle term. What's the top smiley face?
1n.
And the bottom?
Negative 7.
We're multiplying, remember.
Oh, I forgot. Negative 10n.
Now we're adding.
And it's... Okay. Yep.
That works. We have found our solution. Okay, now, watch what I do. I know that it's plus 1, so I get rid of that minus sign, and I know that it's minus 2, so I get rid of the plus sign. So that's the answer. And if I were to check the inside and the outside, which I just did, in other words, when you're dealing with these higher level quadratics, because it has a 5 in front of the n squared, the way you solve them is by using that inside and outside, because it's all about producing the middle term. Now, I'm not trying to produce minus 27. I'm trying to produce this middle term, minus 9. And then the 3 just comes along for the ride. But that's the right answer. Okay?
All right.
All right, let's go to H. Can I pull out a greatest common factor?
No.
How about N?
I do not know.
No, you definitely can. Now, the reason, well, first of all, let's start off with, that's not a quadratic. That is a cubic, right?
A cubic? What's a cubic?
Because it's n cubed.
Oh, okay.
Okay, that's the difference. It's quadratics, n squared is what you have. Cubics, you have n to the third. Quartics are n to the fourth, and so forth and so on. The thing is that cubics are amazingly difficult to factor. So are quartics. So the moment you see a cubic on your test, I want you to think there probably is a greatest common factor there, because they have not taught me how to factor cubics. What they have taught you how to do is to factor quadratics. So if I notice that n can come out, what's left? On H, let's factor an n out. What am I left with?
2n cubed.
2n squared.
2n squared. Plus 5n squared, or just 5n?
Here's what you're doing. When you factor something out, this is what I'm doing. If I have decided that I can factor an n out, then I'm dividing every term by n. And whatever I get is what's left. Well, that's 2n squared. That's 5n. And that's plus 2. That's what you're doing when you're factoring stuff out, is you're merely dividing every term by that.
So we're eliminating the extra variables to create something we can
Yeah,
use.
hold on a second. I made a mistake here. Let's see. That was n times n squared plus 5n plus 2. What we're doing
It's
is
2n
putting
squared
that
at the
into a quadratic. In other words, the problem is now factoring this quadratic.
David, there's it's 2n at the beginning.
Thank you. That makes a big difference, because it wouldn't have factored otherwise. Okay?
Yeah.
But that's how you get this, is you take your greatest common factor and you divide every term by it, and this is what you're left with. Now, when you are factoring, it is almost always a good idea, when you've done this step, is to multiply it back together again. In other words, multiply that to that. Do you get that? Yes. Then multiply that times that. Do you get that? Yes. Multiply n times 2, and you get 2n. So it's kind of always be checking. Always be checking to make sure you have factored it right. Okay? Now we're going to take our quadratic, which they've taught us how to factor, and we're going to factor it without that n in there. So first step in factoring that quadratic
is to split 2n in the first parentheses and just n in the second.
Second step.
We have to figure out the sign, so we put, it's trial and error, so we put a positive negative in the first and then a...
Hold on. The But figuring out the signs is not trial and error. In other words, the first thing I do is I look at that sign. That's a plus. That tells me that both signs have to be the same. They either have to be minus minus or plus plus. To figure out which, I look at that sign. Well, that's a plus also. That tells me absolutely they have to be plus plus.
I keep forgetting to do that.
What's that?
I keep forgetting to do that.
Okay. We're going to get plenty of chances here. Now I look for factors of 2. Well, there's only one set of factors of 2. So this answer is either 2 on the left, 1 on the right, or 1 on the left, 2 on the right. Which one is it?
2 on the right and 1 on the left.
Yeah, and you could figure out why. Because we got to get all the way up to 5. I'm not getting to 5 unless I can multiply that 2 by a 2. Now, that's plus 1n. That's plus 4n. Add them together, I got to my 5n. So I've done it correctly, and that's done. In other words, it doesn't ask me to solve it, it just asks me to factor.
Got it.
Okay. The last, or not the last one, I. That's a quadratic. That is not a cubic. So we don't really expect to be able to factor. When I look at this one here, I see a cubic. First thing that goes through my mind is I'm going to have to be able to factor something out of that in order to turn it into a quadratic, because they haven't taught you how to factor cubics. And believe me, that is a super big step. It is not easy to factor cubics. Just know that. But quadratics, you can always use the quadratic formula. But this is a quadratic. We don't want to rely on the quadratic formula yet. Let's try to factor it. See if we can factor it. If we cannot factor it, then we'll have to use the quadratic formula. That's always what you do. To try to factor it, if you can't factor it, go to the quadratic. First step,
We split 3n, 3 on the first parentheses, and n on the second parentheses.
second step.
We find the sign, and it's going to be, so we look at plus 4, and we know that's a positive.
That
But
tells you both signs have to be the same, is what that tells you.
So but looking at the middle term, it says negative, so they're both negative.
Perfect.
It's going to be a minus sign on both.
Perfect. Now, we actually do have a couple of different factors for 4. We can do 4 and 1, or we can do 2 and 2. Now, what I generally tell people to do is to always start with the 2 factors that are closest together. Only because that's the way Colorado schools, 9 out of 10 of these problems, the answer is going to be the factors that are closest together. 2 and 2 are closer together than 4 and 1. So I'm just going to start with 2 and 2 and see if that works. Still, it's a trial and error process. What's the inside term?
The inside term is negative 2n.
The outside term?
Is negative 6n.
Add them together.
Together, do we add them together, the 2 terms?
Always. You're
Okay.
always combining the inside and the outside.
It's negative 8n when added
That's
together.
correct. In other words, that's what we see. That tells us we did it correctly. One moment, Josh. Session, Sonny's having a seizure and she's right at the top of the stairs. My one time sure she doesn't fall down. Okay, cool. All right, Josh, sorry about that. All right, let's go on. So, J is a little different.
Yep.
Here's the sequence of events that you want to go through to factor stuff. You always want to start with the greatest common factor. Is there a greatest common factor with J?
8.
8 does not divide into 9.
Oh,
In other words, in
3.
order. What's that?
3.
3 does not divide into 16.
Hmm.
So there is not one.
Okay.
This comes under a different category. This is what I call difference of perfect squares, dopes. Okay, this is always the second thing you want to look for. This is first, this is second, and only if neither of those do work, then you have the quadratic factoring. Okay, well,
Yeah.
this is not a normal quadratic. It's missing an n term. It's got the n squared and it's got the constant, but it doesn't have the middle term. So how about dopes? Is this the difference of perfect squares?
Yes.
It is. And if I normally have difference of perfect squares, how does that factor?
I do not know.
Factors a minus b times a plus b. Okay? Now, in my problem, what is a?
A is 16n squared.
That's a squared.
Why is a squared?
A would be 4n. In other words, 4n times 4, you take the square root of that. If you think you have difference of perfect squares, then this answer is the square root. So this, in other words, if I had 16n squared minus 9, that is 4n. And then you take the square root of 9, which is 3, and that's all you have to figure out, because the other is just the conjugate, 4n plus 3. In other words, when you see you have difference of perfect squares, is all you have to do is figure out that first term. And that is 4n minus 3. So the answer is 4n minus 3 times 4n plus 3. That's how you handle difference of perfect squares. Now we have some others coming here, so you're going to get to practice.
So we just found the square root of 16,
No.
and that was our
Well,
A?
yes, that's the way you do it. You find the square root of that minus the square root of that times the conjugate.
What's the...
Is there a greatest common factor there? With number k?
Yes?
With number k?
No.
Okay.
Maybe?
You're right, there is none. So the next thing we checked is that difference of perfect squares?
Yes.
What does it, and the way you do it is you take the square root of that minus the square root of that. What is that?
2 minus 25 is 23.
Hold on. What is the square root of 4m squared?
2m.
Okay. Minus the square root of 25.
5.
That's the first factor. The second factor is always the conjugate. You don't need to do any math. Just take the conjugate of the first factor.
2. I'm writing it down also.
Yeah. The conjugate is where you have the same two terms, different sign in the middle.
So it's just we have to find the square root of both, and then we just place them in parentheses with different
And
signs.
exactly. It's actually the easiest of the methods. Notice that if this was 3m squared minus 25, that's not difference of perfect squares. We don't have a perfect square right there. So in order to use dopes, you've got to be looking at two terms that are both perfect square terms.
So they both have, like, I don't understand.
You have to be able to take the square root of each one using whole numbers.
Okay.
Okay? Now let's look at L. Is L greatest common factor?
No.
Is it dopes?
Yes.
What are the two factors?
3 and 1.
Okay, it's 3x. Always include that variable because the square root of that is 3x. It's not 3.
3x.
However, the square root of 1 is 1. So that's the first term. What's the second term?
3x plus 1.
Yeah, and notice why it's always the conjugate. If I check the inside and the outside, they're always the same. One merely cancels the other, and that's why you don't have a middle term. Okay? So dopes is the easiest of all to do because you know there's no middle term. In other words, the result of multiplying 3x minus 1 times 3x plus 1 is going to be something that does not have a middle term, x, in it. All right, let's go on. But that's the the order you should go in. Is you should first look for greatest common factor, then you should look for difference of perfect squares, then you should look for the standard quadratic factoring, where you separate it into two parentheses and you have to deal with an inside and an outside term. Between those three methods, that'll take care of all the problems they're going to give you.
Got it.
Okay. Now, let me go down a little and let's start looking at problems 3A, B, and C. What's K equal to in A?
K equal to an A?
In other words, here's the equation we're trying to solve. And
Oh.
there's a huge principle in algebra. Never forget this. If you are multiplying two or more things together and you get 0, then one of those things has to be 0. I can't multiply A times B times C times D times E. If I get 0, that means one of those things has to be 0. I can't find 5 numbers multiplied together equaling 0 unless one of them is 0. And that holds true whether it's 5 numbers or most of the time you're going to be looking at 2 numbers multiplied together. And this is k plus 1, that's one number, times k minus 5 is another number, equals 0. That tells me that my solution says k plus 1 has to be 0 and or k minus 5 has to be 0. It's the only way that can be a true statement. Now, solve each equation. If k plus 1 equals 0, what's k equal to?
K equals to 0.
No?
Oh, it equals to the number it's going to.
Subtract 1 from both sides. Solve it just like you would any equation. I would subtract 1 from both sides, correct?
Yes.
That leaves k equal to minus 1. What's the other solution for k? Now I'm solving this one.
It would be negative 5.
No? You're going to add 5 to both sides.
Oh, okay. So it's
K equal 5.
like
Well,
it's like up in the factoring above it, but we're trying to solve what each letter
exactly.
means without the
Exactly.
number.
They've told us the factors. In other words, they've already done all the hard work. Now, doing the rest of it is easy. Problem 3 is as easy as they get that we've looked at so far. Okay. Let's look at problem B. What has to be true? What can I say about a plus 1? And what can I say about a plus 2?
They are both negatives.
They both have to be equal to 0.
Yes.
Because they're being multiplied together and the answer is 0. So we set each one equal to 0. So what's one solution for A?
Negative 1.
And what's the other solution for A?
The other solution is negative 2.
And you'll find that both of those work. Now, in other words, if I go and plug both of those in, I get equations both times. Okay? So this indeed does have two solutions. However, I don't want to confuse you, but the math is such that both don't necessarily have to be equal to 0. One does, only. In a normal quadratic problem like A and B, it ends up that both answers work, almost always. When you get into a little different type of functions, sometimes one of these won't work. And you'll find it out by plugging it in. It doesn't work, and you cross it out. That would only have one solution. But what math tells you is that one of these has to be 0. You cannot have a true statement unless at least one of those is 0. Most of the time, you solve it by letting both of them be 0, and you solve it. Okay? Now, I'm glad they put number C in here. Give me the two equations that I'm going to write to solve for C. What does 4k plus 5 have to be?
Is equal to 0.
Solve that. What's k equal?
It's negative 1.
It's minus 5 divided by 4.
Oh,
Notice the first step of solving that is to move the 5 to the other side, which becomes minus 5, and then divide both sides by 4.
oh.
Here, let's do that step by step, because I'm a little concerned that you don't get that.
I'm just like,
You want to be, if we got to back up if you don't know how to solve that. Okay.
yeah.
So first thing I do is subtract 5 from both sides. It gives me that. Second thing I do, I'm trying to get rid of the 4. So I'm going to divide both sides by 4. Well, that leaves the left is exactly k, and in the right, minus 5/4. So that's the solution I get when I set that equal to 0.
All right.
Now, you still have the other half of it. Also, have to set k plus 1 equals 0. Well, what solution does that give?
-1. No, it equals 0, but it would be -1.
No, you did it right. The thing that equals 0 is k plus 1, not k. In other words, what I know is that that has to equal 0. So I set it equal to 0 and I solve it. Well, that thing's equal to 0 only when k is equal to -1. So this one also has two solutions to it, and they are k equal -1, k equal -5/4. Either one of those, that will remain an equation. If one of those answers and you substitute it in and it did not, equal an equation, in other words, I get 3 equals 1 or something, then one of those solutions doesn't work. Like I said, math does not say that both of these have to be 0. What math says is that at least one of them does. And it turns out that most of the time, both of them do. It's just that there are some equations when you get into absolute values and radical signs and logarithms, a lot of times one of the solutions doesn't work. It's called an extraneous solution. But so far, they haven't given you any of those. All right, how about D? Give me the two equations that have to be, that I'm going to start with.
2m plus 3 equals 0.
Go ahead and solve that.
M will equal -3/2.
Good. And then that part?
The last part is 4m plus 3 equals 0, and m equals -3/4.
All right. Now, what you're going to find is that both of those are always going to work when you have just a quadratic. Always. In other words, they haven't given you one yet where one of the solutions is extraneous. So let's not even talk about that until we find one. At this point, we're just assuming both solutions always work. Now, this one's not factored, right? In other words, that one's factored, that one was factored, that one was factored, that one was factored. Those were easy. Well, we got to do the middle step here. We have to factor it first. Once we factor it, then we're going to do exactly the same thing we did with the other four. We're going to set each one equal to 0. So how do you factor that?
So you make two parentheses, you put x's in both of them, and it is and the sign would be minus.
Both signs.
Both signs are minus.
Okay.
And we have to figure out a factor of 11.
No, factors of 24. You're always looking for factors of the right-hand term, the constant. That's what I want, is factors of 24. Remember, the last step of FOILing is to multiply those two constants together to get that term.
Oh, so I forgot. So we use 24. We find factors of 24 that equal 11.
That add, because add plus sign to 11. Well, first of all, let's find all the factors of 24. 24 and 1, 12 and 2, 6 and 4, 3 and 8. You see how I got the last set?
Yeah.
We just found our answer. I was looking for factors of 24 that add to 11.
So it would be 3 and 8.
And I don't even have to decide where the 8 goes or where the 3 goes. In other words, this is a 3-step factoring problem only, not even a 4-step. So this number E is actually one of the easier problems we've come up with. Now tell me the solutions. If x minus 3 times x minus 8 equals 0, what are the possible answers for x?
X would be, for the first one, X would be positive 3, and for the second one, X will be positive 8.
Yeah. And notice that when you plug each of those in, when I plug the first one in, that becomes 0. Well, 0 times anything is always 0. And when I plug the 8 in, that one becomes 0. So both of them work. Okay? So let's do F. Again, they've given it to us in standard quadratic form. So the first thing we got to do is factor it.
2 parentheses, n in both. It is both signs are positive, so addition signs. And I know the answer already. It would be 5 and 2.
That's fine. Yeah. No, you don't have to do it slow. If you can recognize the answer immediately, well, then just go ahead and put it. And you know that's going to be right because that's plus 5n. That's plus 2n. That gives you plus 7n. And that is our middle term. However, we haven't finished the problem yet. So all we did was factor it. And what I know is that if all of that's equal to 0, what are my solutions for n?
So n for the first one will equal negative 5. And n for the second one will equal negative 2.
Beautiful. All right, let's see what else we have on this page. Okay, we got more. All right, now they give us a quadratic, but it's not in standard form. In other words, they're getting gradually more and more complicated. Excuse me, that's not even a quadratic. Notice there's no x squared term. It's strictly, so what's the first step on number 4a?
We have to add
Combine,
20.
combine like terms.
Oh,
Well, we already have that over there. What happens when I combine minus 4x and minus 6x?
minus 10x.
Now solve that.
Minus 20 equal minus 10. What do we, I don't remember how to do it.
Well, I'm glad, because that allows me to talk about solving equations. When you are solving an equation that only has one variable, your entire goal is to get rid of everything but what's with x. In other words, the last line needs to be that. So the only thing with the x right now is it's being multiplied by minus 10. So you do the opposite. I'm going to divide both sides by minus 10. That way, that minus 10 crosses with that minus 10, and my final answer is x. And what's the result of that on the left?
Negative 10 equals x.
No. What's minus 20 divided by minus 10?
2.
That's your answer.
So x equals 2.
Yeah. Right. No quadratic, no having to factor. B is the same way. It's a linear function. I see a variable, but it's not squared. If it's not squared, then it's a linear function. So what do I do with B?
B, you add common factors.
Okay.
So it'd be
next line.
So first we would have to add 1 to 5. So it'd be 6 6. Okay.
Okay, now what?
1 second, let me write down. 6 equals 6 minus 2. And then we would have to
We want our last line
subtract.
n equals.
We would have to.
What's the first thing on the right side we want to get rid of? Is it the 6 or the minus 2?
We want to get rid of the 6.
Yes, because I can subtract 6 from both sides. So when I subtract 6 from both sides, this is what I'm left with. Now what do I want to get rid of?
2.
Minus 2.
Minus 2.
I'm going to get rid of it because the minus 2 is multiplying, I'm going to divide. That gives me my n. What's on the left side?
1.
0 in the numerator always means 0 as an answer.
So n equals 0?
0 by minus 2, you get 0. It doesn't matter what I divide 0 by. If I divide it by minus 112, I get 0. If I divide it by 1,000,000,000, I get 0. 0 divided by any number is 0, just like 0 multiplied by any number is 0.
All right.
So n equals 0 is the only solution that satisfies that. If you were to put in any value other than 0, that would not be an equation. But if you put in n equals 0, you got 6 equals 6. Okay, let's look at number C.
All right. So
now,
first,
let me say something here because I think this is important and most people don't realize it. The first thing I want to do is I want to gather all like terms, right?
Yes.
What that means is I'm going to gather all my variables on one side, all my numbers on another. So,
yeah, so you have to switch numbers.
The decision you have to make is which side are you going to put your variables on? Always.
I like to put
your numbers on. In this problem, which side does it make sense to put the variable on?
The left.
Because it leaves you with a positive coefficient. In other words, 8x minus 7x is 1x. That's why I put it on the left side. I don't want to subtract 8x from both sides and be left with a minus x over there. It'll make the problem harder. In other words, which side you decide to put your x's on depends entirely on whether you're going to put a positive or a negative coefficient. Now, it actually works either way. I could put my x on the other side and I'll get the same answer. It's just that I'll be dealing with a lot of negative signs. Okay? So the fewer negative signs you can deal with, the less likely it is you're going to make a mistake. Now, what number goes on the other side?
The other number we put on the other side is...
I'm combining that and that, but I'm not combining them. I'm adding 2. In other words, the number has to go on the right.
The number on the right will be 7.
Minus 7.
Oh, yeah, minus 7.
Minus 9 plus 2, which is minus 7. Okay? And that's our answer. We're done.
Oh, actually was... Oh. I thought we would have to do something extra for it. But
these are linear functions are pretty easy to solve. They're much easier than quadratics. They kind of have this page backwards. They started with quadratics and they went to easier linear functions. But let's make sure you can do all the linear functions. On D, which side am I putting my variable on? Left or right?
putting variable on the right.
That would give it a negative coefficient.
So we would want to have it have a positive coefficient.
So
Right.
which side am I going to put my variable on?
We would have to put the variable on the left side.
And what is it? When I combine both those variables on the left side, what do I have?
Positive A2. Positive 5A.
Well, here's what I'm doing. I'm adding 5A to both sides. All right? In other words, that gets rid of that. What's the left? What is A plus 5A?
It would be 5A squared. No, it would be 6A squared.
It's just 6A. When you are adding, you got 1 apple and 5 apples. If you got 1 apple and 5 apples, they add to 6 apples. If you're multiplying, they multiply to 5A squared. But the very first thing you have to make sure you do is multiply and add when appropriate. This is adding. Now, put the numbers all on the right. What goes on the right?
5 from the left, so you'd minus 5 from the left and minus 5 on the right.
So what goes, that gets rid of the 5. What goes on the right?
0.
Now what?
We divide it by 6.
So what's A equal to?
0.
Perfect. And again, that's the only answer. There's only one. When you solve linear equations, you only get one answer. When you solve quadratics, you generally get 2 answers. Okay, let's look at E. First step on E.
First step is to, that's a lot of, we combine like factors.
Okay, let's do it one at a time. In other words, let's just combine the p's on the right. In other words, let's not do all the steps at once. So that's a good first step, right?
Mm-hmm.
Now, which side am I going to put my p's on?
The left
No.
side.
If I put it on the
Right
left,
side.
it's going to have a negative coefficient. If I put it on the right, it's going to have a positive coefficient.
So, okay, so it's going to be right side, and that's going to turn into 9p.
7p.
Oh,
I
yeah,
have to
7p.
subtract a p from both sides. Now, what's the numbers? The numbers have to go on the other side.
We add 8 to both sides.
Good.
So we would have 9 on the...
No. Let's make sure you're not doing your arithmetic wrong. That's what's currently on the left side. If I add 8 to it, what do I get?
7.
Yes, 7. So now I got 7 equals 7p. What's p equal to?
It will equal to 7?
How do you... Okay, I'm at this step right here. 7 equals 7p. I want my final answer to say p equals something. Well, there's a 7 multiplying that p right now. How do I get rid of that 7?
By dividing it by 7?
By dividing both sides. You cannot just arbitrarily divide one side of an equation by another. What you can do is the same thing. Whatever you do to one side, you got to do it to the other. By dividing both sides by 7, these 7's cancel, and I'm left with my p all alone. But the left side becomes 1. 7 divided by 7.
0. 1.
1.
No,
Not 7 minus 7. What I notice is that you get your addition and multiplication mixed up sometimes, and you get your subtraction and division mixed up sometimes. Well, that's the first thing you need to be absolutely clear of, is whether you're doing addition or subtraction or multiplication or division. Makes a huge difference.
Real quick before, okay, just real quick thing. So when we were at 1 equals 7p minus 8, did we
There.
subtract? I thought we added 8 to the right and then added 8 to the
First
left.
of all, we never were there. Let's start from the beginning again. We've got p minus 1 equals, I'm going to combine those two, so we got 8p minus 8. Okay? Now, I see that if I put my p's on the right, I'm going to maintain that positive coefficient. So I'm going to subtract p from both sides. That gets rid of this p, and I'm left with minus 1 equals 7p minus 8.
Okay.
With me?
I was
Now,
so
what's the next step?
The next step is to, so
We're trying to get rid of everything that's
oh,
with the p.
okay.
And we got a
That
minus
makes
8 that's with it, and we got it something else multiplying it by 7. Always get
we
rid of what's being added or subtracted first.
we add 8 to -1, and the negative takes 1 out, so it would be 7. It would just be 7.
So now we got
On the,
7p equals 7.
I forgot to keep the negative sign on the 1 on my paper. I was so
Now,
lost.
since we want p all by itself, I got to get rid of the 7 that's multiplying p. So I got to divide both sides by 7. And then I get 1 equals p.
All right.
All right, let's do a few more of these. These are good practice for you. So on f, which side are we going to put our variable on, the left or the right?
The left.
Okay, nope.
Oh, the right to maintain a positive.
Yeah, what's it going to be?
We're going to have to subtract 5p from the left and
From both sides.
yeah, from both sides.
So that's going to
And
leave
then
us
we
with
will,
that, which means where am I going to put my numbers?
we're going, so 3p. And right next to 3p, it's going to be 4. And then before 3p, it's going to be equals 14. No, 14 equals 3p plus 1. No, plus 4. Then then from the right, we subtract 4. And we subtract 4 from both sides. That leaves 10 on the left.
Actually, it doesn't. Minus 14 minus 4 is minus 18.
Oh, I keep forgetting to put down a negative.
So this is our next step. Now what? You can't drop negative signs. Dropping negative signs means you don't know how to do the problem. You drop one negative sign, you're getting the answer wrong. And that is probably the most common mistake I run into in my math students. Everybody wants to drop negative signs. They hate negative signs. So, boy, if you could drop one, you do it. But that's a big mistake. You do not drop negative signs ever. If there's a negative sign, put it in there. If there's 2 of them in a row, put them both in there. If there's 3 in a row, put all 3 of them in there. Don't drop them. So the way I got to this second step was, okay, here's what I got. 3p plus 4 equals minus 14. So I got to subtract 4 from both sides. That becomes minus 18. That stays 3p. Now what?
And then we divide both sides by 3.
So what is p equal to?
6.
Negative 6.
Negative 6.
You see why it's negative?
Yes.
Because I'm dividing both sides by a positive 3. I got to get rid of that 3. So I got to divide by a positive 3. And when I take minus 18 divided by a positive 3, I get minus 6.
Got it.
Okay. I just want to do a few things for a moment. Tell me these answers without a calculator.
Without a calculator.
Mm-hmm.
So we were doing what we did for the one before solving the
I
equation.
want you to do some arithmetic for me. Because if you are having problems with arithmetic, we need to go back and cover the rules. Because you're never going to solve equations if you can't do arithmetic. It's impossible. I want to make sure you can do this arithmetic.
That will equal 16.
No.
Negative 16.
Here's what you do. The reason this is confusing is because you're looking at 2 dashes, right?
Yeah.
That is a negative sign. That is subtraction. So the way you handle subtraction signs is you make them addition signs and you change the sign that comes after. So I turn this into, I change that to a plus and change that to a minus. So this is the same problem as this. And if I give it to you like this, you're never going to miss it. What's minus 9 plus minus 7?
Minus 16?
You don't miss those. It's easy to add 2 negative numbers. What's difficult is to take a negative number and subtract a positive number. That's what everybody has troubles with. And I mean, a lot of my students do not know how to do that problem. Okay, let's do another one. Minus 9 minus a minus 7. Now what? That's a negative sign. That's a negative sign. That is a subtraction sign.
Negative 2?
Correct. In other words, I start by turning my subtraction sign into a positive and change the sign on whatever follows. So now the problem becomes minus 9 plus 7. And that is minus 2. But what really gives people problems is when you give them 2 minus signs. What's that?
Wait, what's the name? What are you asking again? Like how to figure this one out?
Yeah.
It would
minus 5 minus 8.
It would be negative 13.
Good. I think you got it. Okay. I just had to make sure you could do those like that. Because really, if you can't do that one, you're not going to be able to do any of these problems. You've got to be able to do the arithmetic 100% perfect in order to solve equations. Okay, that is the secret of algebra. It's not the algebra that's tough. It really isn't. It's the arithmetic that's tough. It's just that most people who have grown up on calculators lose some of their ability to do simple arithmetic. And you can't lose that ability. When you're solving algebraic equations, you got to be able to do it in your head. There are just too many calculations that you're always making involving small numbers. So if you don't know what minus 1 minus another 1 is, you're not going anywhere. You got to be able to do that. Okay? You can see that every problem we do here is a series of very small calculations. I had to add that 1 to that 5, and then I had to subtract 6, and then I had to divide by minus 2. In other words, there's all of these single-digit calculations you have to do. And it doesn't make sense to use a calculator. It just slows you down too much. So you got to be able to do single-digit operations in your head. All right, I apologize. I've run you past the time a little bit. Let's see. This is Thursday. So I will talk to you next Tuesday.
Cool.
All right, Josh. You have a good week.
All right.
I'll talk to you then.
All right. See ya. Bye.